Yo, it's video number 3. Just got cut off for a quick second while I was doing a problem. So basically, you want to use your law of sines because you have an angle and its corresponding side. So you have the angle of 90 degrees with its corresponding side. You can see in triangle number 3. So you have an angle, its corresponding side in triangle number 3. And what you want to do is you're going to use the law, and you already have the other angle that you need across from the corresponding side that you're looking for. So you can use the law of sines. So we use the law of sines. We have sine of 90 degrees divided by 913.636 feet is equal to the sine of 37.8 degrees divided by h. Now what are we going to do? We're going to solve for our height. We multiplied by h on both sides. Okay, so that left us with sine. What's the sine of 90 degrees? The sine of 90 degrees we know is 1, so let's just go ahead and make that easier. So it's just h over 913.636 feet is equal to sine of 37.8 degrees. So can I calculate that? Yes. 900 multiplied by 913.636 feet multiplied by 913.636 feet. What does that give you? Your height of your monument is going to equal 559.974 feet. Wow, I rarely use my solutions on that one. That was a fun problem. Sweet. Good stuff. So, I guess I'll go on to the next one, just to kind of help you out if you're still struggling a little bit. But the main idea with these problems is you have to identify what you know and what you're looking for, and try to figure out ways that you can get what you're looking for using the law of sines and the law of cosines. It's pretty cool. Well, even if you don't think so, whatever. If you do, then welcome to the party. If you don't, then you're not cool. So, use a diagram below to determine 3 things. We have to determine 3 things. The height of the kite. So the height of the kite. So whenever we're saying we're going to determine the height of the kite, that means the height of the kite above the ground. So, okay, here's this bad boy. The height of the kite above the ground is straight down, right? So that's going to be a 90-degree angle right there. The height of the kite is this guy right here. Alright? So let's call that, instead of calling it height, h, let's just call that c. Little c, side little c. Then it's saying, use a diagram below to determine the height of the kite. So the height of the kite, we're going to say, is little c. The distance from the first observer to the kite. So I called this guy the first observer. I called the guy that was closest. Hold on one second. So I call this guy observer number 1. And then the other guy I called observer number 2. That's just a little technical detail that I think will kind of help you while you're solving this problem, just as if you go ahead and identify which ones are your first and second observers. But these, so we're saying we want to find the distance from the first observer to the kite. So the distance from the first observer to the kite. So let's call that little a. And then the distance from the second observer to the kite. This is the second observer to the kite. Let's call that side little b. So now what do? We said that we have to first draw all the triangles that we see. Well, here's a triangle, then there's a bigger overall triangle. So let's just go ahead and do that. Triangle 1. So you guys should be able to do that on your own, and you can just check your work against mine. But let's just go ahead and do that first triangle with the 62 degrees as one of its angles. doesn't make quite a 90-degree angle with the guy. So this is 62 degrees. Okay, so that's a 62-degree angle right here. Then we have the length of that, or the distance from the first observer to the second observer is 30 feet. And then we have the hypotenuse was side A, B was one of the legs. We're just redrawing this triangle over here. So across from side A, we're going to have angle A. Big A. Across from side B, we got angle B. And then we have that other angle. We'll label it in a minute. So let's go ahead and draw the other triangles that we see. We see the other triangle from the second observer. So triangle 2. Triangle 2 we see is this guy. Where you know that this is 90 degrees because C is the distance from the ground, or the distance a kite is above the ground. So that forms a 90-degree angle with the ground. So that's 90 degrees. Then you know the other angle, this is 78 degrees. Okay, then you also know that this is side B. Okay, triangle 3. Triangle number 3. So let's just draw the bigger triangle. The bigger triangle that we see is this triangle. 62 degrees. And we know that this is A and this is C. Okay? So I've labeled everything that I know, except now I'm going to just go arbitrarily and label the other angles that I have. So let's say we're going to call this angle, so we have ABCs, so let's call this angle D. So let's call this angle D on triangle 2. I mean, you can label these any way you want them. I'm just labeling them the way that I want to label them. So in triangle number 2, I went ahead and labeled that as angle D. So straight across from angle D, you're going to have little side D. Little d, baby d, whatever you want to call it. Biggie D is the angle. Alright, cool. So you have triangle number 1 where you have angle E. Let's just go ahead and label it as angle E. Directly across from angle E we know is side E. So we have angle A. Directly across from angle A is side A. And yeah, that's triangle 1. We have everything labeled. Triangle 2, we have everything labeled, yes. Triangle 3, do we have everything labeled? We have anything that we can carry over from either triangle 1 or triangle 2. Well, this angle right here has to be angle E, so angle E plus angle D for this angle right here. But maybe that's not even that important. So what are we looking for? We're looking for 3 things. We're looking for the height of the kite above the ground. We're looking for the distance from observer number 2 and the distance from observer number 1. These aren't labeled as ABC as in the problem. In the problem it says, okay, part A, find the height of the kite. Well, that's actually what we labeled as side C. It's just, we just use different letters. I mean, this is just part 1, find the height of the kite, that's side C. Part 2, find the distance from the first observer to the kite, that's letter A. Or side A, and then it says the distance from the second observer to the kite, that's side B. Whew, I gotta pee, but I gotta keep doing this video, so let me hurry through it. No, I'm just kidding. About hurrying through it. Really do gotta pee. Cool. So now we have the 3 triangles. What do we do? What do we do? Well, triangle 1. Let's go ahead and start with triangle 1. Let's see if we can use our skills, the pre-cal, and figure some stuff out. So, can we figure anything out? We have an angle we knew that in triangle 1, its neighboring angle was 78 degrees. So whenever that neighboring angle is 78 degrees, can we figure out angle A? Yes, because we know the measure of angle A has to be 180 degrees minus 78 degrees. Why? Because whenever you have a horizontal line, anything that intersects it, so it intersects it this way, that's 78 degrees, right? Well, you know that straight across has to equal 180 degrees. So the distance that's left, for the angle that's left from that 78 degrees to the 180 is 102 degrees. So the measure of angle A is 102 degrees. So we have a side of E. We have E, side E. We have angle A, and we have the other angle. If we have two angles, can we figure out the third angle? Heck yeah. So the sum of the angles has to equal 180. So the measure of angle E has to be, what is it? 62 degrees, so 180 degrees minus 62 degrees plus 102 degrees. So whenever you take that difference, you're going to get the measure of angle E to be 16 degrees. Well, that's not your answer, but that's just the measure of angle E. So the measure of angle E is 16 degrees. Well, let's put that in there. 16 degrees. Now, if we have the measure of angle E, we have side E, we have an angle and its corresponding side. Oh my gosh. Oh my goodness. So we have an angle and its corresponding side. We have another angle. Wow. Can we solve for one of the other sides? Yeah. Oh, wow. So, what are we going to use? The law of sines. So we're going to use the law of sines. So, sine of angle A divided by side A has to equal the sine of angle E divided by side E. We know side E, and we know angle E, and we know angle A. We can find side A. So let's plug in. So the sine of angle A is 102 degrees divided by A. Angle E we knew was 16 degrees. Side E was 30. How are we going to solve for A? Multiply by A, multiply by A. That gives you the sine of 102 degrees is equal to A times the sine of 16 degrees divided by 30. So how are you going to solve for A now? Multiply by 30 on both sides. Multiply by 30, so you get 30. Sine of 102 degrees is equal to, wait, you can't see that, can you? Nope. Alright, so I'm going to write that over here. So we're going to bring this up over here. So we're going to say that that's going to give us the sine, A times the sine of 16 degrees is going to be equal to 30 times the sine of 102 degrees. How do we solve for A? Divide by the sine of 16 degrees, divide by the sine of 16 degrees. So your A value is going to be 30 times the sine of 102 degrees divided by the sine of 16 degrees. So your A value is 106.460 feet for this side. So whenever it tells you, well, what does letter A represent? Well, that's the distance from observer number 1 to the kite. Wow, I just solved part B. So I just solved part B. Hold on, I think that's part B. Yeah, so I just solved part B where it said the distance from observer 1 to the kite. I found this length. We're going to continue on the next video.